Howdy, my name is Emilio, and today I'll be showing you the Make a Quake demo. In this video, I'll show you how to set it up and how to start it up. Towards the end of the video, I'll show you the physics behind this and how it all works. So let's go ahead and move on to how to set it up. First, you're going to start by powering on the computer. Then you're going to connect the DAT to computer via USB and also connect the geophone to DAT to the channel 1. Then you're going to place the geophone into the sand. Make sure it's not too tight so the geophone can actually move freely. Now you're going to put on the lid into the sand and geophone box so that it is isolated from the rest of the system. Then you're going to log on to the Earthquake account in the computer. In here, you're going to click on the DI100 ANT on the desktop. Then you're going to click on Edit, Channels, and click on the I, R, and C, then click OK. Next, you're going to click View, Format Screen, and one waveform. Next, you're going to press the F key 3 and adjust to 2500 as shown, then click OK. Next, you're going to click on the 1 = 1 on the left side of the screen. Click Edit, Channel Settings, click on Gain 20, then you can click OK. Next, you're going to go to the Scaling tab, click Row, and you can repeat this step at least 6 times. Then you're ready to jump and make a graph. Make sure that you can demonstrate this beforehand so that it is ready. Step as many times as you need, and you can try to make as many pics as you want. In the picture shown, you can see in more detail how to connect the geophone to the DAT. As you can see, the red wire will be the positive end, and the blue wire will be the negative end. As said before, we're going to connect this to the channel 1 of the DAT. Next up, I'm going to explain more in detail how the physics of the geophone works and what makes the Make a Quake demo work. So by jumping, you create waves. These waves will then travel through the board that you're jumping on and travel through the sand to the geophone. The active element of the geophone consists of a mass hanging on a spring wrapped around the mass in a strand of wire. Surrounding the wire-wrapped mass is a magnet that is fixed to the earth. This will be equal to this pointy thing in the geophone. So this is the magnet that I'm talking about. As the earth moves, the magnet moves up and down around the mass. The magnetic field of the moving magnet produces an electrical voltage in the wire. Now, you may remember this concept as being eddy currents, and this is one of the main concepts that we learned through the geophone. The geophone itself uses the concept of eddy currents of a changing magnetic field around the mass, and eventually creates this current. This voltage can be amplified and recorded by a simple voltmeter. It is relatively easy to show that the voltage recorded by the voltmeter is proportional to the velocity at which the ground is moving. Instead of the voltmeter, we have an instrument called the DAT that interprets the voltage and sends it to the computer to be displayed as a wave. And that's pretty much how the Make a Quake demo works. It's a pretty simple concept in which we use the physics concept of eddy currents to make the whole thing possible. Thank you so much for watching, and I hope you learned something new today.